Logistic models. Logistic models are going to replicate nature more than perhaps any other model that we've discussed. Excuse me. With that in mind, if you'll recall, the exponential models also replicate nature pretty well, but an exponential model will never continue forever necessarily. If we look at the population of bacteria in a petri dish, it'll usually increase exponentially. But at some point, you have to imagine that that petri dish is going to run out of space, or they're going to run out of nutrients, or something is going to happen to where they stop increasing, at least at such a rate that they have been. That point on the curve of a logistic model is called the inflection point right here. Again, this is the point at which the rate of increase changes. Notice that this curve is increasing the entire time, but as of this inflection point, that rate of increase changes. The inflection point is also the point at which we go from concave up and increasing to concave down and increasing. When you're concave up and increasing, the difference between for this increment of time, difference between these two y values is fairly small compared to the difference between these two y values for the same increment of time. So it's increasing faster and faster through this portion, this first portion of the curve. Then once we reach that inflection point, or it changes from concave up to concave down over the same interval of time, that increase in y values is decreasing as we go further to the right on the curve. So we've got increasing faster and faster. It's speeding up the increase. And over here, we've got increasing more and more slowly. That's what happens at the inflection point. That's kind of the hallmark of a logistic model. For example, the human race is currently increasing at an exponential rate. That doesn't mean that it's going to increase at an exponential rate forever. If we look at the population of the human race on planet Earth, for example, at some point in time, the Earth will reach its maximum human population, and it'll start to dwindle. Now, it's not to say that the human population is going to increase and then just turn around, but rather it'll likely continue to increase just at a slower and slower rate. Look at China, who just recently repealed their law, but they were restricting families to only one child. That's the same kind of concept. If the whole world at some point started restricting families to one child, then we would still increase our numbers because life expectancy is getting longer and longer. We'd still increase the population of Earth, but at a slower and slower rate if everybody's only having one kid. So if we look at this this logistic model, the human race could be somewhere in this region of the logistic model right now. Again, an exponential model is the way the human race is currently changing, or the human population, but the likely we're only on this portion of a true logistic curve, because eventually we're going to hit that inflection point, that point at which our increase in numbers, instead of speeding up, begins slowing down, and then we'll increase those numbers until we get close to that limiting value of L. L is different for every population, and the problem with trying to figure out where we are on this logistic curve now as a species, the problem with it is there's no way of figuring out what the carrying capacity for the Earth is for humans. So we can't figure out what that L value is, what that upper limit for our population is, and thus we can't determine what kind of inflection or a logistic model we're talking about. Another form of a logistic model is a decreasing logistic model. Notice it's decreasing forever, where this one was increasing forever. This one's decreasing, and it goes from concave down to concave up, where it decreases at a faster and faster rate here and decreases at a slower rate here. So over time, the decrease slows down. And that happens at the inflection point. Okay. Our basic logistic model looks like this. If the exponent on the exponential, so e to the bx, if the exponent here is positive, then we have a decreasing model, decreasing logistic model. If the exponent is negative, then we have an increasing model. We'll deal more with these logistic models in time. And if you have any questions, please let me know.